Hello and welcome back to Ganesh Institute. In today's video, we are again taking up a topic from probability, and that is conditional probability and the law of total probability. So let's talk about conditional first. So let's say you are given with a particular event. Let's say you roll a fair die. So when you roll a fair die, what all events are you having? Maybe one, two, three, four, five, or six. All these events. So, if you are asked that you are rolling a die, you need to find out the probability of getting an odd number. So, one event is an odd number, and another event is, but that odd number, it is given that it should be less than or equal to 3. So, two things are given. You need to find out the probability of first event, which is called as prior probability, priori probability, or prior event. And this is the conditional event or given event later on. You write it by PA by B, wherein it is the probability of happening of an event A when B has already occurred. Okay? So given condition is B has already taken place. So in that case, the formula is for PA by B, it is you need to find out the intersection because B has already been taken place. This you need to keep in the denominator because you are picking out from the given event that this is going to be happening. And the common part will go in the favorable outcomes. Okay. So tell me, given is less than or equal to 3. So out of sample space, this event becomes, the event becomes 1, 2, 3, right? And the first probability, the prior probability is getting an odd number. An odd number are 1, 3, and 6 out of these 6, correct? What has happened? 1, 3, 5, right? Odd number. So what is common? Intersection we have to find out. What is common in these two? So that means a number which is odd but less than 3. That is 1 less than or equal to 3. And 3, that means 2. Two events or outcomes are there. And total is of 3. Yeah. So this is how you are supposed to find out the conditional one. When it comes to total probability law, so before that, I want to tell you about the independent events. Do you know what are independent events? So let's say these are events, as the name suggests, that happening of an event doesn't depend on happening of another event. So in that case, the intersection is actually the multiplication of individual ones. Okay. So for instance, if I am tossing a coin, so if it is a fair coin, sample space is going to be head and tail. Probability of getting a head is 1 out of 2. Probability of getting a tail is also 1 by 2, right? This is what? This is equally likely outcome. Right? Now, if I say that there is one event A and it is saying that it rains tomorrow and its probability is 1 by 3, let's say. Okay. If you are asked that find the probability of getting a head given that it will rain tomorrow. Do you really think that there is any correlation or dependency of one event with other? Will it rain? So will it affect the happening of coming of ahead? No. So basically, these are two independent events. The result of coin does not have anything to do with tomorrow's rain. So what we'll write, though the formula for conditional probability is PA intersection B by PB. So that is here, instead of A, we have H, and instead of B, we have A. So we'll write as H intersection A upon PA. So what's the intersection? There is actually, these are independent events. So we'll simply write the product and then PA. So it is actually the happening of event, the prior event only, happening of a head, and that is 1 by 2. Then if I ask that, okay, you toss a coin and that too repeatedly, until you observe that first tail at which point you get, you will stop. You need to find out the probability of x is equal to 5. X is here total number of coin tosses. Now tell me, question is saying you repeatedly tossing a coin and you will stop when you get a head. That means there are 5 coins tossed. So at last, 1, 2, 3, 4, 5, at last you must be getting a tail, because that's why you stop there at 5. So this is head, this is head, this is head, this is head. So all these are independent, right? So you'll simply multiply all of them. So probability of getting a head 1 by 2 for this, 1 by 2 for this, 1 by 2, 1 by 2, and for tail also 1 by 2. So this is the answer. Now when it comes to law of total probability, it is being derived from conditional probability only. You know that by conditional probability, you have this formula that A intersection B is, you have this formula that PA by B is PA intersection B by PB, right? Now, if you get the value of PA intersection B from here, what is it? You will take it to the left hand side. So PA by B into PB, right? Now, if I want to ask from the Venn diagram, this is A, this is B. Tell me, what is the probability of A? What is the probability of A? It is basically A intersection B, and only A is making PA, right? So PA intersection B plus PA minus B. And this PA minus B can also be written as PA intersection B complement, right? Correct? So can I write this in place of intersection? So this will become as PA by B into PB, and this will become PA by B complement into PB complement, right? We are just putting B complement in place of this because this is our given conditional value. So this is how you need to calculate. For in case of total probability, the probability of an event will be the summation of conditional one and the summation of product of conditional and PBs. Okay. It can be any eyes, right? Let's try one question. If you can read it for me. I have 3 bags and each contain 100 marbles. So we have 3 bags. Let's say this is my B1, this is B2, this is B3. Each one of them is carrying 100 marbles, and the classification is such that 75 red, 25 blue. In bag 2 we have 60 red, 40 blue. In bag 3, we have 45 red, 55 blue, right? You choose one of the bags and then pick a marble from the chosen bag. So you are choosing one of the bags. So there is one probability of choosing a bag, and then you are picking a marble. You need to find out the probability that it is red. So one of the bags have been chosen, that is your given probability, but that has to be red. This is your prior probability, right? So tell me, firstly, if I need to find out probability of getting a red, by total probability law, it will be R by B1 into P B1 plus R by B2, second bag, PB2, plus PR by B3, PB3, right? From the derivation and the formula. Okay, so I need to find out all these values, right? Let's find them out one by one. So first up, PR by B1. These are simple, PB1, PB2, PB3. So probability is favorable outcomes upon total number of outcomes, right? We have only 3 bags and we need to choose one out of them. So it will always be 1 by 3, right? Equally likely. Now for R by B1, we have to have red ball that has to be chosen from B1 and probability of B1 in denominator, right? So or you can simply, without solving it, you can read it from here. You need to choose red marble from bag 1. Red marble from bag 1. What's the probability? 75 out of 100. That is 0.75, right? Similarly, R by B2. Red marble from bag 2. Red marble from bag 3. So red marble from B2 is 60 by 100 and this is 45 by 100. That is 0.60, 0.45, yeah? Now substitute all these values and get the answer. So 0.75 into 1 by 3, 0.60 into 1 by 3, plus 0.45 into 1 by 3. Solve them and you get the answer. I'm hoping that you've got the concept of total probability, conditional probability, and independent events. If so, then don't forget to like, share, and subscribe my channel. Till my next video, take care of yourself. Bye-bye.